guys, so today we're going to be going over two powerful series tests, can't talk, the ratio and the root test. So let's get right into it. I'm going to explain each one step by step, and by the end you should be masters of this. Now, let's start with the ratio test. So they're going to give you, right, some series, right? So what you do is you take the limit as n goes to infinity of an plus 1, so you just add, you replace n with n plus 1, and I'll show you what that means, divided by the original series. And now, if L is less than 1, the series converges. If L is bigger than 1 or is infinity, it diverges. But if L equals 1, the test fails. Now, this might sound a little weird. The test fails, yeah. So what this means is you're going to have to use another test. You might have to use p-series or geometric series or telescoping, whatever, but you cannot use ratio. Ratio test fails. So let's go to our first example. So we have this series 2 to the n over n factorial. Now remember, it was a n plus 1 over a n. So now, what do I mean by a n plus 1? Well, a n plus 1, I'm literally replacing the n with n plus 1. So 2 to the n plus 1 over n plus 1 factorial, and divided by the original series, and this is all limit as n goes to infinity. Now this looks really complicated. I'll show you. It's actually not that bad. Let me just rewrite it to n plus 1 over n plus 1 factorial. And so if we multiply this out, right, the denominator flips, so this is n factorial over 2 to the n. Now, this looks super complicated. You might be thinking, how the hell am I supposed to simplify this? Well, let's think about it. So, 2 to the n plus 1 times 2 to the n. There's a couple ways you can think about it. You can use exponent rules, right? If you divide, right, if you divide two exponents with the same base, you just subtract 1. Or you can think about it like this. Let's pretend we made this n was 1. So this is 2 to the 1, and this is 2 to the 2. Obviously, 1, 2 would cancel, and you'd be left with 2 in the numerator, right? And this works for any. This could be 2 to the 100 and 2 to the 101. There's going to be 1, 2 left over in the numerator. So this means that this cancels and this cancels. We're just left with 2 in the numerator. Now let's go on to the factorials. You guys should know what factorials are, right? So if it's, for example, 2 to the 2 factorial, it's 2 times 1. If it's 4 factorial, it's 4 times 3 times 2 times 1, etc. So basically, it's the same thing. So how I like to think about it, eventually it's just going to be intuition. Let's pretend that this n is a 4. So this would be 5 factorial, and this would be 4 factorial. Well, if this is 5 times 4 times 3 times 2 times 1, and this is 4 times 3 times 2 times 1, these all cancel, and these all cancel, and you're left with 5. And 5 was n plus 1. So that's kind of how I think about it. So let me just erase all this. So basically, we're going to be left with just n plus 1 in the denominator. So this becomes limit as n goes to infinity of 2 over n plus 1. Now, what is this? Well, if we quote-unquote plug infinity in, the denominator is going to be growing not exponentially, but huge and huge. This is going to approach 0. So now, what did we say? Well, we said if the limit is less than 1, it converges. Is 0 less than 1? Yes. So by the root test, or the ratio test, this series converges. In the AP exam, you're going to have to write it. So I'm just a quick example. Since L, you have to define what L is. L is less than 0, or less than 1, then AN, that series, I don't want to write it out, converges by ratio test. By ratio test. There we go. So you're going to have to write a little bit more detail than I did, but this is kind of the gist of it. So now let's go on to our next example. Same thing. N cubed over 3 to the n. Well, remember, we just, instead of where the n's are, we just put n plus 1. So n plus 1 cubed over 3 to the n plus 1. Never forget the limit sign. They grade you on the limit sign. So n cubed over 3 to the n equals n plus 1 cubed over 3 to the n plus 1. If you divide something, you multiply by its reciprocal, so it's 3 to the n over n cubed. Okay. Now, this one's a little bit trickier. Let's, again, you're going to build up a little bit of intuition, but let's just say n is 3. So this is, we can just write this 3 to the 3, and this is 3 to the 4. Well, they all cancel except for 1, 3 in the denominator, right? So since the exponent right here is 1 bigger than that, that means there's going to be always 1, 3 left in the denominator. Now, let's think about this. N plus 1 cubed over n cubed. We can simplify that down because... Well, we can't simplify this down because they're not the same base, right? So let's just leave it as it is for now. So we have limit as n goes to infinity of n plus 1 cubed over 3 to the n cubed. Now, how about I expand this out? Alright, so now let's expand out the numerator. So we're going to get, if we use like binomial theorem or Pascal's triangle, you'd get 3n squared plus 3n plus 1 over 3n cubed. Now, if you guys remember to your pre-calculus class when you guys were talking about n behavior, how I was taught was basically you can kind of ignore the smaller exponents, right? Because at huge numbers, at n equals 100 million, this measly little 3n won't matter. This measly little 1 won't matter. So now we have n cubed over 3n cubed. The n cubes cancel, and you're left with 1/3, right? So now it's easy, since it's kind of the same thing we did here. Since L is 1/3, which is less than 1, then AN converges by root test. Now, for most kids, like a lot of the hardest part is here, simplifying it down. But I promise, the more you practice, the more you're gonna gain some intuition, right? You won't have to plug in 3 plus 1 and 3 here and then figure out, oh, this is 1 left, this is 1 more, whatever. You're gonna gain that intuition, but as always, like everything, practice makes perfect. So that's root test. That's root test in a nutshell. There are some harder ones where you might have to do a little bit more simplifying, but I think this is the majority of the questions you'd see on your AP exam. In the next video, we'll go over much more in-depth problems, the hardest ones that you'll ever see, just so everything on the AP exam is so easy for you. So let's now move on to root test. So again, they give you some series. This time, you take the nth root of that series and take the limit of it. And the same kind of rules apply. If the limit is less than 1, it converges. If the limit is bigger than 1, it diverges. And if L equals 1, the test fails. So let's get right into our new example. So 3 to the 5th to the n power. Now, like how root test says, all we have to do is take the nth root of it. So we take the nth root of an, which is this inside part. So it's be nth root of 3 over 5, and it's technically like absolute value. Well, the nth root of 3 over 5 is just 3 over 5, right? And this is all limit as n goes to infinity. Is 3 over 5. And 3 over 5 is less than 1. So that means this series converges by root test. Root test. Alright? So, pretty simple, right? I will say though, I forgot to say this. Ratio test, I think you'll be able to solve 95% of the problems with ratio test. It's super easy to use, and maybe there's like a 5% chance it'll fail and you'll have to use another test, but most of the time, and a lot of people do use ratio test most of the time. But anyway, back to root test. This is simple, right? All we have to do is just take the nth root. And if 3/5 is bigger than 1, or is less than 1, it converges. Boom. Now, let's try our next example. So, this series of n over n plus 1 to the nth power. Again, we just take the nth root. So the nth root of n over n plus 1, absolute value, all that stuff, to the n. This just is n over n plus 1, and I forgot the limit. Guys, never forget the limit. You're going to get points taken off. Limit. Sorry, I'm writing so messy, but so, right? Limit is n of n over n plus 1. Now, you could use your n behavior, right? And just look at the leading powers and know this is 1. Or you can kind of see, well, this is infinity over infinity, which means we can use L'Hopital, which means it's the limit as n approaches infinity of the derivative of the top over the derivative of the bottom. This is 1. Alright, so now, what does our root test say? Well, let's go back and see. Oh, if L equals 1, the test fails. Okay, so that means root test can't solve this. So by root test, no, you should. So for this problem in particular, since they asked to write it in root test, you just say this series cannot be solved. Be solved using root test. Using root test. Now, I will say, this L'Hopital thing, it can get a little bit tiresome at sometimes, so I really recommend you guys kind of get your n behavior down, right? You know this is a 1 and this is a 1, right? Because this is like a pre-calculus kind of thing. You guys know that you just look at n behavior, right? You just look at this, cross out this, because right, if it's 100 million over 100 million plus 1, this 1 like doesn't matter. This is as close to 1 as possible. So that's all you guys got to do. So I hope you guys enjoyed this video. That's all you really need to know. That's the basic rules of ratio test, root test. If you guys have these on lock, I promise you'll get 99% of the questions right on your AP exam. Again, next time we'll be going over some much more complex problems. But I hope you guys enjoyed. If you did, leave a like, subscribe. If you have any questions, leave them in the comments. Or if you have any feedback, leave them in the comments. But I will say, the root or ratio test does not mean divergence. Just because it fails doesn't mean it diverges. It just means you have to use another test. So a lot of people get that confused, right? So for this one, they might say, oh, the ratio test fails. This is diverge. That's wrong. That's wrong. You can't just immediately say it. It might diverge, I don't know, but you can't immediately say it. All it means, if the root or ratio test fails, all it means, use another test. You'd have to use another test. That's it. But, a lot of people just kind of assume, oh, since it failed, it diverges. No. You have to just use another test. It might converge, it might diverge. You never know, so just use another test. But yeah. Again, if you have any questions, comments, leave them in the comment section down below. Thank you guys so much for watching, and I'll see you guys in the next video.